Sometimes we meet a polynomial like this one, x to the sixth minus 5x cubed plus 6, and we'd like to factor it fully. And we think to ourselves, I don't know how to factor that guy, but I sure know how to factor this guy. But what's the difference between these two? Well, the difference here is I've just let u stand in for x cubed, right? X cubed squared is x to the sixth, x cubed. This process, where we replace usually a more complicated variable expression by one that's easier to work with, this is called substitution. And it's an advanced technique that we can use when factoring. Right, so what would we do? We would let some different letter equal a more complicated expression, and then we can factor the new polynomial and then substitute back. So what would we do here? We would factor our u squared minus 5u plus 6. How would we do that? Well, we'll get a u squared and a 6. We want two numbers whose sum is negative 5 and whose product is 6. We could have negative 1 times negative 6. That's negative 7. Negative 2 times negative 3. Oh, there we go. Negative 5. So we'll want negative 2u, negative 3u. What are our common factors? Up here I'll have u, and down here I'll have 2. U times what is u squared? U times u is u squared. Is u times 2 negative 2u? Oh no, this had better be a negative 2. U times negative 2 is negative 2u. U times what is negative 3u? U times negative 3 is negative 3u. Negative 3 times negative 2 is in fact positive 6. So this expression factors as u minus 2 times u minus 3. But of course this doesn't factor our original expression. Why? Because this hasn't got any u's in it. We need to substitute back. I'll get my original polynomial factoring as x cubed minus 2 times x cubed minus 3. Now notice, my only hope to factor these two binomials further would be if they were differences of cubes, but 2 isn't a perfect cube, 3 isn't a perfect cube, so I can't go any further with that. Alright, I'm going to give you one of these to try telling you what substitution to do. And then I'll give you another one to try and see if you can spot the substitution. Factor the polynomial x to the fourth plus 3x squared minus 4, using the substitution u equals x squared. And remember to be on the lookout to be able to factor the binomials that you get. Pause the video and try this now. Alright, noticing that x to the fourth is x squared squared, we'll have u squared plus 3u minus 4. So we're looking for two numbers whose sum is positive 3 and whose product is negative 4. Oh, and negative 1 times positive 4 does it right away. So I'll have negative u, positive 4u. In this row, my greatest common factor is u. In this row, it's 4. U times what is u squared? U times u is u squared. So u times 4 is indeed 4u. U times what is negative u? U times negative 1 is negative u. Negative 1 times 4 is indeed negative 4. So this factors as u plus 4 times u minus 1. I'm not finished yet though, right? I still have to substitute back. I'll have u, remember, is x squared. x squared plus 4 times x squared minus 1. Ooh, x squared, notice, is not a special form, right? It's a sum of squares, which we can't factor. X squared minus 1, though, this is a difference of squares, so I can factor this further. All right, now I'm going to give you one to try where I don't tell you what substitution to make. Factor this polynomial using substitution. Pause the video and try this now. All right, now we could have chosen to multiply this whole thing out, simplify as much as we could, and see what sort of nice things we get. But look, we can substitute with u as x squared minus 2, and then we're really factoring u squared minus u minus 2. Well, how do we get two numbers whose product is negative 2 and whose sum is negative 1? Maybe you already see it. Negative 2 times 1 is negative 2. Their sum is negative 1. So we'll want negative 2u and positive u. All right, let's see. In this row, my common factor is u. In this row, the best I think I can do is plus 1. U times what is u squared? U times u is u squared. Is it true that u times 1 is positive u? Yeah, no problem. U times what is negative 2u? Well, negative 2. Negative 2 times positive 1 is negative 2? Yes, this factors as u plus 1 times u minus 2. All right, we can substitute back now. We'll have x squared minus 2 plus 1 times x squared minus 2 minus 2. Oh, but each of these factors is pretty easy to simplify, isn't it? This will be just x squared minus 1, and this will be just x squared minus 4. Oh, hey, that's kind of cool, isn't it? This is a difference of squares. We can factor it as x minus 1 times x plus 1. And this is a difference of squares. We can factor it as x minus 2 times x plus 2. And now we can't factor these any further.